to standard form. So in the last lesson, we did kind of look at how you could go from standard form to general. I could expand this out. I could remove the brackets, collect like terms, and I could get it into this ax squared plus bx plus c form. But this standard form is the form that is, it's a great form to have your equation in, because this form gives me the vertex, which gives me my axis of symmetry. The a value tells me if it opens up or down, so now I have a minimum or a maximum value, and I can sketch the graph. Whereas with ax squared plus bx plus c, at best I can tell you what the y-intercept is, because that's whatever the c value is. And I can probably tell you if it opens up or down, because again, the a value, if it's positive, it would go up, and if it was negative, it would go down. But I can't tell you where it crosses the x-axis. If it crosses the x-axis, I have a lot more work to do. So the standard form equation is the form that we prefer. It's the form that will allow us to find the characteristics of the graph. So in order to write this form, we need to do something that's called completing the square. So we need to look at the idea of creating perfect square binomials. So if we look at x plus 4 squared, x plus 4 squared means to multiply x plus 4 times x plus 4. So if we FOIL this out, if we expand, use the distributive property, I will get an x squared, a 4x, a 4x, and a 16. Which when I simplify it, I get x squared plus 8x plus 16. What I would like you to do is I would like you to finish the next 3 binomial expansions. So x plus 7 squared equals what?
X squared plus 14x plus 49.
X minus 5 squared.
X minus 10x plus 25.
And x minus 1 squared.
X squared minus 2x plus 1.
Minus 1 or plus 1?
Plus 1.
Plus 1. So from these 4 questions, do you start to see a pattern that emerges in how I can get my first term, my last term, and the middle term without, or just looking at this part? So the first and the last term are usually the easiest ones, and they're usually the ones that we always get right. I know I'm going to get an x squared plus 16, or an x squared plus 25. How do I get that middle term? Double the product of this. So double 4x, I get at 8x. Double negative 5x, I get negative 10x. So if I had x plus a squared, and I expanded that out, what would I get? So my first term would be what?
X squared.
And what would my last term be?
A squared.
And what would my middle be?
2ax.
2ax. Double of the product. So the product is ax, and I double it. If I make it an x minus a squared, what changes?
Becomes minus 2.
It's minus 2ax. Okay? So that's working from expanding it out. The next part looks at factoring. If I factor this using my sum and product charts, 2 numbers that multiply to 9 and add to 6. 3 and 3. So I'd have an x plus 3 and an x plus 3, which I can simplify as x plus 3 squared. So now do the next 3. So what would x squared plus 12x plus 36 give me?
X plus 6 squared.
X squared minus 4x plus 4.
X minus 2 squared.
Yep. And then the last one, x squared minus 16x plus 64.
X minus 8 squared.
So this is expanding out, this is factoring. in part C, we're going to do what we call completing. We're going to complete this expression to make it a square. So if I look at this, and I look at the x squared and the 6, and then the 9, if I didn't know that this was a 9, how could I figure it out? How could I use either the x squared or the 6 to get the 9? Okay, so what's half of 6? Square 3? What's half of 4? Square it? Half of 12. And I square it? So if I take half of this middle term and square it, I'll get that last term. So half of 2. 1 and 1 squared. That becomes my perfect square. So now when I go to factor this perfect square, what will I get?
X plus 1 squared.
Okay, so let's look at the second one. Half of 18. Square it. And what does that factor to?
X plus 9.
Do you notice that 9 came up again? That 9 was when I halved 18. Half of 3. Okay, but let's leave it as a fraction. Instead of 1.5, let's leave it as 3 halves. And what's my next step? Once I take half of this middle term, what do I do with it? Double it. What did I do here? After I found half of it, what did I do with the 9? I squared it. So I square this. So when you're squaring a fraction, you square the top, which would give me, square the bottom, so I'd get 9/4. And remember what I said about this one. Half of 18 was 9, and my 9 appeared here. So when I go to factor this, my 3 halves appears there. And what sign goes in the middle? Negative. Okay. Take half of 1/4. So imagine it. If I take a quarter and I cut it in half, what am I going to have? An eighth. Square it. What will you have? 1/64. And then when I factor it, I'll get x minus 1/8. So the biggest change is that now we start dealing with fractions. Or there's the potential to start dealing with fractions when I'm starting to do my quadratic factoring. And we only do that when we're talking about our perfect squares. So the process of adding this constant term, my 81, my 1, my 1/64, to create a perfect square is what we call completing the square. And if you notice with our standard form equation, this right here is my perfect square. So what I'm going to do with my y equals ax squared plus bx plus c is I'm going to create a perfect square within those first two terms. I'm going to make my perfect square in here so that I can then factor it to look like this. So to complete the square, we already talked about this. We take half of the coefficient of x. So I take half of 2 and then I square it. That's what the bottom line is indicating. So we're going to step into class example number 1, and then I'll look at the flow chart because it's easier to explain it that way. So I have y equals x squared plus 10x plus 16. What I'm going to treat as my perfect square is my x squared plus 10x. The 16 we're going to put off to the side. It's still there, but I'm just going to put it further away and leave a big gap. How do I complete the square with x squared plus 10x? I take half of 10 and I square it. So what's half of 10? Square 5. Now if I add 25 to this equation, have I changed the value of the equation? Because I added 25. So how can I cancel out that value?
So 25 on the other side.
Or, so if I put 25 on the other side and I brought it over here, what would happen to the 25? It would become negative. What's 25 minus 25? 0. Have I changed the value of the equation now? No, because I added 0. I just changed what 0 looked like. So now, there's my perfect square. The x squared plus 10x plus 25 is my perfect square. When I factor it, what do I get? So I get x plus 5 squared, and then I take my negative 25 and I add it to the 16. And what do I get? Negative 9. So in this equation right here, I could tell you it opened up, and I could tell you that it was at 16 for a y-coordinate. With this equation here, I can tell you it still opens up, but now I can tell you that the vertex is at negative 5 and negative 9, which means it's going to cross the x-axis, which is another good thing to know. If you put these into your graphing calculator, you will get the exact same graph. So when we go to do that, I clear the graphs that are there. If I put in the first graph, x squared plus 10x plus 16, my signs didn't go in. And then when I go to put the second graph in, I'm actually going to change the thickness of the line so that I can see as the calculator draws it for me. So then bracket x plus 5 bracket squared minus 9. So there's my first graph, and there comes the second graph. And if I'm still not certain, or I still don't trust that they're the same graph, if I look at the table, the y values are the same. So the input of x gives me the same output for both graphs. So the flow chart says step 1, take half of the numerical coefficient and square it. This is the numerical coefficient they're speaking of the x term. So half of that, square it, I get 25. Add and subtract this. So I add a 25 and I subtract, because it keeps the value the same. And then form a perfect square, write it in factored form, and then simplify. So if I look at class example number 2, a function is defined by f of x equals x squared minus 9x minus 20. Determine the minimum value of f by writing the function in standard form. So when you're asked to write it in standard form, it means complete the square. So f of x equals x squared minus 9x, and then I leave a space and put my minus 20. So to find out what I put in this space, I take half of that coefficient. So half of 9 becomes 9 halves, and I square it. What do you get when you square 9 halves? So we get 81 quarters. So I'm going to add 81 quarters and subtract 81 quarters. Because that's the same as putting in a zero pair. Does not change the value of my equation. Then I factor my trinomial because it's a perfect square trinomial. So when I factor it, I'll get x minus what? 9 over 2. And that 9 over 2 I can get two ways. I can get it from here, or I can get it by square rooting this. The square root of 81 is 9, square root of 4 is 2. And then I have to combine this part here. So how many quarters are in negative 20? So in 1, there'd be 4 quarters. In 2, there'd be 8 quarters. In 3, there'd be 12 quarters. So in 20, how many quarters would I have? 80. So this is a minus 81 over 4 and a minus 80 over 4. So what do I get when I combine them?
1/4.
No, because they're both negative.
So it would be like -60.
Yes. Which you could use your calculator to add the two fractions. My graph opens up because I have a positive a value or I don't have a negative in front. Minimum value is your Q. So the minimum value is negative 161 over 4. Okay, I'm going to ask you a question, or we're going to skip to class example number 3. If I have to complete the square on this equation, f of x equals 3x squared minus 18x, and then I have this plus 20. What problem am I going to run into? What do I notice compared to what we've done?
Well, it has the 3 in front of x squared.
It's a 3 in front of the x squared. What if I said do this? Would that make it easier now? So what did I do?
Took out the Grace common.
I took out the greatest common factor. Basically what I did is I took out whatever the coefficient is in front of the x squared. Because when I go to complete the square, and if you go back to your standard form, it's written like this. So do I ever have a coefficient in front of the x? No, that coefficient was my a value. So when I have something in front of the x squared, I remove it out. And sometimes it'll happen very nicely when you remove it out. You're going to get something that works out, and sometimes you're going to get more fractions to deal with. That's the extent of what happens as we get into the higher levels. So now to complete the square, I take half of 6, which is, so then I square it and I get, so I add 9 and I subtract 9. We have one last little glitch. So when I go to complete this square right here, what would I get? So when I go to factor it, sorry, I shouldn't say complete the square. When I go to factor x squared minus 6x plus 9, what do I get?
X minus 3 squared.
Okay. And I still have this 3 out in front. This 3 is multiplied by everything inside the bracket. So when I go to take this negative 9 out of the bracket, I have to multiply it by 3. So the way that I write that, and I can put the 3 in front of the 9 if I want. So now I have 3 times x minus 3 squared minus 27 plus 20. If I simplify that, what would I get?
-7.
Minus 7. So does the graph have a minimum value or a maximum value? How do I know it's a minimum? A is positive. So A is greater than 0, which means it opens up. So I have a minimum value. And what is that minimum value? -7. So now we'll look at the flow chart, because the flow chart gets to be a lot more in this one. The biggest difference, first of all, use the coefficient as the common factor and factor it out. Coefficient was 3, I factor the 3 out. Then I do like I did before, take half the numerical coefficient of x and square it, add and subtract it inside the brackets. Add and subtract it inside the brackets. Then multiply the term in which has been subtracted by the coefficient right here. So when I go to remove this -9 out of the brackets, I have to remember to multiply it by the 3. And then I combine. 2 more examples. Y equals 7 plus 10x minus 2x squared. If I want to write this in standard form, how do I start? What would you do first? Okay, so how would you rearrange it, Hannah? That would probably be a good first step to start off with. And then that way it's in my ax squared plus bx plus c, and then I can start through my process. Okay, so what would I do next?
Take out a -2.
Oops. And if I take out a -2, what would I be left with?
X squared minus 5x.
And this plus 7 I'm going to put over here. So right from this point in time, can you tell me if the graph opens up or down?
Down.
Down, because I've got a -2 that I just factored out. Okay? So I can even answer that. Opens down. So now how do I complete the square inside the brackets? What do I do with 5?
Divided by 2.
So when I take 5 and I divide it by 2 and I square it, what do I get?
5/4.
So I add 25/4 and I subtract 25/4. Now I can factor these 3 terms. So when I factor that trinomial, what do I get?
X minus 5x.
Okay. And when I go to remove this -25/4, what do I have to multiply it by? Not just 2. -2. Good. So -2 times x minus 5/2 squared. When I multiply -25/4 by -2, what do I get? What do I get? 25 over 2. Yes. So I'd get 50 over 4, which would reduce down to 25 over 2. And 7 would be how many halves?
14.
So I have 25 halves and 14 halves, which together, my final equation, -2 times x minus 5/2 squared plus what?
39.
So my vertex would be what? my vertex is my P and my Q value. Good. Okay, last example. Express the following function in completed square form and then use the form to determine the zeros of the function. So what would be my first step?
We need to factor out a 3.
Okay, so if I factor out a 3, what am I left with? X squared minus 4x. And then this negative 8 will stay on the outside. Complete the square. So to complete the square, I take half of 4, which is, and square it. So I add a 4 and subtract a 4. Factor my perfect square to give me what?
X minus 2.
And then I remove the negative 4, but I remember to multiply it by 3. Negative 4 times 3. Negative 12, and negative 12 minus 8. So that's f of x in standard form. If I want to find the zeros, how do I find the zeros? So on the graph, what do the zeros correspond to? The x-intercepts. So how do I find x-intercepts? Let y equal 0. So I get 0 equals 3 times x minus 2 squared minus 20. So what would be my first step? Add 20 to each side. Next step.
Divide by 3.
After I divide by 3, and when I square root both sides, what do I do in front of the square root with the 20 over 3?
Plus minus.
Plus minus, because it could be a positive or a negative. And then my final step,
Add 2.
add 2 to each side. So 2 plus or minus the square root of 20/3 would be equal to x. So the question does say to the nearest hundredth, so if I actually calculated this out, I'd have 2 plus the square root of 20 divided by 3, which would give me 4.58 to the nearest hundredth. I think I've shown you this before, but just to review, I'm lazy, I don't want to have to retype the whole thing again, so if I go second and the enter button, it pastes what I just typed in back, but the cursor's sitting here, so I can move my cursor back, change plus to minus, and then I get my next answer, negative 0.58. So instead of me having to type it all over again, because I don't want to have to type it again. Okay, I want to adjust the questions that I originally assigned because I'm not going to give you that many.